to kind of separate these tabs so you could read all of them, but then what I want you to do in the same order, like flip it over and make sure you can read the other 4, so it looks like I still have to separate them a little bit further. Well, hon, it's got to separate a little bit further so you can read all 4 of them. Okay, so once you have the ability to read all of your tabs, we're going to fold them, but it's not going to be exactly in half. So you want to look at this side, rhombi, square, rhombi, and we're making a booklet. You got it. Okay, I'll pass these around in a second, but the staplers are the easiest to use. A table, line it up, staple it close to the edge, but you still have to staple it. It won't stay together. I'm going to use color. As for assignments that you've done this week, that way maybe this will answer some questions. Look and read it. Ooh, were you able to open the tutorials and push the button and listen?
Yes.
We're not going to do everything in this booklet today. It'll take too long. I'm going to skip around and do the most important parts today so that you have stuff to go home with and use over the weekend. So I'm just folded it. I did not open the first one. I folded it all the way up to parallelogram. Second tab. And then, like I said, I'm going to use color to do some things in here. Okay, I can tell, Tyler, yours is done wrong. Because my back has nothing on it. He folded it wrong. No, don't take it out of order.
This is the first one.
Yeah, he folded it the other way.
So it just has to be different. Oh. I thought you
All right. Where's my stapler around this? Better question. Who has not stapled it over there? Okay, get it from Alex next. And then there's this coming up the row. All right, you guys. We're going to do the definition of a parallelogram. That is not the definition.
No, I'm not switching sides.
So that's not the first thing I'm going to write. That is not the definition. Oh, okay. No, parallel is the right answer. But then I was thinking, shoot, we got to build up.
That actually makes a lot more sense than
Because it's called a parallelogram. Jordan, Derek, hi. Because it's called a parallelogram, the definition of a parallelogram is a quadrilateral in which opposite sides are parallel. Now, people ask me about spelling parallel. People spell parallel wrong all the time. There's one R. There's two L's in the middle. Literally in the middle of the word parallel are two parallel lines, which is the symbol for parallel. See it right there? Okay. One R, two L's. So that's the definition of a parallelogram. What's a quadrilateral mean? Four sides. Okay. So my very first detail about this, opposite sides are parallel. So in my picture, I'm going to mark my opposite sides parallel. Number two, opposite sides are also what? Congruent. And you guys are more than welcome to use the symbols for congruent or the symbols for parallel. So opposite sides are also congruent. So in my picture, I'm going to mark congruent. Congruent. Opposite angles. Opposite angles. Opposite angles are congruent. Congruent. Opposite angles are congruent.
Is it square?
Say that again?
Is it square?
Oh, I gotta tell you something. Because of my sickness, my ears, I have like fluid in my ears. I can't hear very well at all. So normally I can't hear very well, so now it's even worse. So if I ask you what, like 100 times, it's because I can't hear. Did you say a square?
Yeah.
What about a square?
Is it a parallelogram?
Yeah. That's why we did parallelograms, and then we did rectangles, rhombi, and squares next. So all we've done this past week have been all parallelograms. Consecutive angles. So consecutive means like next to each other, this one, then this one, or this one, and this one, or this one. The ones that are consecutive are what? Supplementary. And what's supplementary mean? Sum is 180 degrees. If you look at these, they are not congruent. Diagonals what each other? Bisect. Which means to do what? Cut in half, yeah. So I'm going to show that the diagonals are split into two congruent pieces. Sorry. All right, let's see some examples. One thing that I wasn't here to tell you guys, and I really want to make sure that you understand this. When they name, like a parallelogram, when they name a quadrilateral, these letters go in order around the figure. They do not go A, B, C, D. They do not do that. They go around the figure A, B, C, D. They go around the figure. And if you have your picture set up wrong, and then you start talking about angle X, A, and angle D, potentially you're going to get the wrong answer because you have your picture drawn wrong. So the ABCD goes around the figure. This says that measure of angle A is X degrees, and measure of angle D is 2x minus 3. So now we look at A and D and we see where they are located. What do we know about these two angles from up here?
What angles?
A and D. Are they opposite angles, or are they consecutive? Or are the only things that talk about angles? Are they opposite or consecutive? They are consecutive. They are one after another. They're next to each other. So what does it say about consecutive angles? Supplementary, which means their sum is 180. So we add them up and set it equal to 180 degrees. So one thing that makes geometry a bit challenging for some people is all this vocabulary. If you know that these are consecutive, then you know they're supplementary because I have it written down right here. But sometimes you can even look at the picture and be like, yep, those are not equal to each other. They have to be the other thing. They have to add up to be 180. So we're going to solve this equation. I'm going to get 3x minus 3 equals 180. I'm going to add that 3 and get 3x equals 183. Divide by 3, x equals 61. Example 2. X, Y, Z, W is a parallelogram. So let me draw it. X, Y, Z, W. So I wrote the letters around the figure. It has diagonals, X, Z, and Y, W. Let me draw those diagonals. X, Z, and Y, W. They intersect at point A. Point A in the middle. If X, A is 3M, and ZA is 5M minus 4, find M. I can't hear you. So what from up here are you using? Diagonals bisect each other. That means they are equal. So yeah, we say 3M equals 5M minus 4. So I'm going to subtract 3M from both sides. I get 0 equals 2M minus 4. Add 4. 4 equals 2M divided by 2. M equals 2. Example 3, we have to find X, Y, and Z. And I'm looking at X first. Now, chances are 50% of you are thinking it's 35. Everybody think it's 35? Nobody's going to admit it. It's not 35. There is not anything up here that says that this angle is bisected. There's not anything up here that says that this angle is cut into two equal angles. So we cannot assume. So there's other ways of figuring this out. What do we know about angles? There's two things up here about angles. What do we know about angles? opposite angles are congruent. Does that help me to find x? Does that help me to find z? What's z? 120, okay. So knowing that opposite angles are congruent helps me find z. So consecutive angles are supplementary. Does that perhaps help me find x? 120 plus this entire angle is supplementary. So I'm going to take that entire angle, which is x plus 35, and I'm going to add 120 degrees, and that should equal 180. Those are supplementary. And then I really quickly added that, subtracted from 180, and I got x equals 25 for my x value. I just did it real fast, okay? So you can see that x is not the same as 35 degrees. Please do not assume. Would y be 25? Well, the whole opposite angle is congruent. So this whole angle and this whole angle are both going to be 60 degrees. That doesn't tell me what y is. What?
Would it be? No.
There's a few different ways of figuring this out. To me, this one seems the easiest. What do we know about all three angles in a triangle? They add up to be 180. It's called the triangle sum theorem. So if I take 180 degrees and I subtract off the 35 here and I subtract off the 120, then I should get this little part here. I get this little piece here, which is 25 degrees. So what does y have to be to make 60 with the 25? It's hard to tell it's 25. What does y have to be? Derek, what's the answer? Okay. Now, same way. Yeah, some people said that in my last class too as well. So alternate interior angles would be another way of doing it. Okay? One more thing about this. Do you notice I didn't put any degree symbols on these? Why? Because I'm being lazy. Who was that said something? Oh, was that you, Rachel? Because who already has them? In the triangle? Yeah, so I'm finding z, and then when I plug it in over here, I plug it into z degrees, so the degree symbol's already there. So we don't need to repeat the degree symbol. All right, move on to rectangles. So yesterday, you should have learned that a rectangle is a parallelogram. Did you learn that a rectangle is a parallelogram? Did you or did you not? I wasn't here. So a rectangle is a parallelogram. That means that everything that a parallelogram has, a rectangle has too. But a rectangle is more specific. What does a rectangle have that not all parallelograms have? What makes it a rectangle? Four right angles. So if you actually looked up the definition of a parallelogram, I mean, not a parallelogram, a rectangle, If you actually looked up the definition of a rectangle, it would be a parallelogram with 4 right angles. Even though you were not taught that in kindergarten.
What is it, like a square?
Rectangle, but a rectangle isn't always a square, yeah. Yeah. Did you do something like that?
That was the hard thing.
What?
That was like the thing that they first.
Who's they?
Our mark.
I didn't know if you meant they was the video you watched or they was a long time ago. Okay. All right. So these first 5, these are all the exact same 5 from parallelogram. The first 5 we have already filled out. We're going to fill out again.
Oh, good.
What?
Because I have filled this out wrong. Like I did whatever.
That's exactly what I did mine,
And I erased it.
Oh, you wrote the first 5 on the wrong page?
Yeah.
Oh, yeah, they're all the same. Because they're all parallelograms.
All of them, like for every single.
No. Just all the ones we've done so far through rhombus. Square. Mhm. Okay, so opposite sides are parallel. Opposite sides are also congruent. We've got congruent. We've got opposite angles. I don't need to mark those because they're 90s. Consecutive angles are supplementary. And I don't really need to mark those because they're both 90. And then diagonals bisect each other. For right angles, and then diagonals themselves are congruent. So when you see me draw my bisecting part, I actually showed that all 4 little pieces are going to be the same, since the diagonals themselves are congruent. Now, as examples, I'm going to come back and fill out examples when we have time. I just want to get through this top part of the pages today. We've done some examples already with the parallelogram. Let's get through rhombus. So a rhombus is also specific parallelogram. What do you guys know about rhombi? 4 congruent sides. Parallelogram with 4 sides. Now, I will tell you, this picture is not drawn to scale. This is not exactly a rhombus, but we're just going to go with it. Because it is a parallelogram, I also know that opposite sides are parallel. Sides are congruent. Angles are congruent. And consecutive angles are supplementary. Each other. The diagonals themselves are not congruent, and I think you can see this. What did you learn about the two diagonals in a rhombus? Diagonals are perpendicular. You can also use a symbol. Bisect opposite angles. So that means over here, this angle is congruent to this angle. This angle here is the angle. Okay, and then we could do some examples, but for it, right? Parallelogram. But it's more specific, a parallelogram that has what? That's a rhombus. That's part of it, though. For congruent sides, and what about the angles? They're all congruent? What are they? If they're all congruent, they're all right angles. So you weren't wrong by saying that they're all congruent for right angles. Rectangle. So a square is if I had a rhombus plus a rectangle. That equals square. So square is a parallelogram. That means opposite sides are parallel. By the way, this picture is not a square. But we're going to pretend opposite sides are congruent. Opposite angles are congruent. Consecutive angles are supplementary. Diagonals bisect each other. 4 right angles. Diagonals are perpendicular. For congruent sides. And diagonals bisect opposite angles. I'll put a little asterisk on that one because I'm going to put a little picture, write something on the picture with that one. Diagonals bisect opposite angles. So this angle right here are all 45. This one's 45, this one's 45. They're all 45s. So now we're going to do the examples on this page. Am I going too fast? Are we doing okay? I mean, this should be stuff that you've already kind of gotten. We're putting it all together. Measure of angle AED. So I'm going to highlight that so we know exactly what angle we're talking about. Measure of angle AED. A to E to D. Measure of angle AED. That's this one right here. Is 5x plus 5. We have to find x. What information do we know about this angle besides it about this angle in a square? Austin? Did you say it's right? Yes, it is 90 degrees. It's in a square, so this has to be 90 degrees. Next one says measure of angle B. Okay. Example 3. MH equals 8. We have to find the length of AH. Nothing in our stuff above says anything about the lengths comparing to the length of the diagonals. They do not compare those whatsoever. All I know is if this is 8, then so is this, and so is this, and so is this. What? Okay, you're thinking out loud. I also know that this is 90 degrees because it's a square, and as soon as I know that that's 90 degrees, I'm going to do something here. This is a right triangle. Now you should have, but you guys have told me before you didn't, you should have learned in a previous course that when you have a right triangle, the two sides that are called the legs, the two sides that make the 90 degrees, and then the hypotenuse that's opposite the 90 degrees, there is a relationship between these sides, and it is called the which says a squared plus b squared equals c squared. The biggest thing about that people has to be the one that's not touching the 90 degrees. 90 degrees. Or you got the wrong side. Eight squared plus 8 squared equals c squared. So 64 plus 64 equals c squared. So 120 equals c squared. The length that I'm trying to find, this AH, is just c. So I have to take this equation and solve it for c. How do we do that? Oh, divide? No. Square root. And when you square root, you always have to include a plus minus. 8. Let's see if that can be simplified. Now, I'm just making this go a little faster. You would actually have to think through this rather than me just telling you it. There is a perfect square that goes into 128, and I know this because I'm going to go just this step up here. When I got 128 in the first time, 64 plus 64. So I basically did 64 times 2, right? Times. So 64 goes into 128 2 times. So this would become 8 square root 2. And that is the length of my AH. Now if you need a decimal, like I'm not sure, I know that there's something like this on the coloring page. Question? Oh yeah, I'm going to talk about that in a second. Let me come back to that. But if you do need a decimal, then just type in square root of 128, which is approximately 11.3. Now, very good question. I was going to come back to that. See how I never talked about that plus minus again, and I didn't put that in my answer. So plus minus is the correct thing to do when you're solving an equation with a square root. However, what are we actually finding? Which is a length of a side. Do I ever have negative length? So I did not include the negative because that is impossible. Okay? But I like reviewing this because people forget. All right, one more. If MS equals 3 and AS equals 3, find the perimeter of the square MATH. Oh, okay. You guys weren't amused. I see. I see your faces. Okay. So I know this. What? I can't talk right now. This is a right angle because diagonals are perpendicular. Guess what? A right triangle. This would be the C side of that right triangle. Here we've got the A and the B. Can I just write without talking? Okay, once you get 18 equals c squared, square root, I think about the plus minus, but then I also think about reality. It's not going to be the minus. Okay. I'm going to break down that 18. That 18 happens to be 9 times 2, because that's how I got 18 in the first place. So I get 3 radical 2 for my c value. That is not what I'm trying to find when I'm done, though. How do we find perimeter? Add up all 4 sides. So you can do this with addition or you can do it with multiplication. I'm going to do it with addition because I feel like I can explain it better. If you're in Algebra 2, you should be able to do it with multiplication. Because I know what you guys are studying right now or just took a test on. You just take a test. So I'm going to add up all four sides. And when I add up these four sides, this is the tricky part. This number out front is how many I have. Square root 2 is what I have. So 3 is how many, square root of 2 is what? So I'm saying this as 3. I have 3 square root of 2's plus 3 more square root of 2's plus 3 more square root of 2's and 3 more square root of 2's. How many square root of 2's do I have? I have 3 square root of 2's plus 3 more square root of 2's plus 3 more square root of 2's plus 3 more square root of 2's. Now I have 12 square root of 2's. So the square root of 2 itself didn't change because that's what I was adding. The number in front, how many I had, is what changed. So this is our perimeter. If you needed a decimal, you type that into your calculator, and I forget the answer. It's approximately 16.97. Your assignment this weekend is to get caught up with anything that you didn't finish, because I'm going to collect everything from the past week on Monday. The coloring thing was really the only thing that was due Monday, but I haven't collected anything. You had a maze. And then the big ideas online, I mean, that, I don't collect, it goes in. But the big ideas online. Yeah, so I'm going to collect the maze and coloring, but your big ideas online should also be finished. Okay, and then I'll post this video if you need to go watch it.